Let's understand oncology table listings and figures. Introduction. Now, table listings and figures are essential outputs in clinical trial data analysis, providing a structured way to present study results. They enable stakeholders, including clinical research, regulators, and sponsors, to understand the trial's findings effectively. Now, here's how to understand clinical trial results using table listings and figures with an oncology focus. Now, understand one thing, we have a clinical trial data, right? Now that data is analyzed through some softwares in such a way that we get some information, meaningful information. Now that information, it needs to be presented in somehow so that the common layman person, like a person who is not even educated, but that person will remember that picture or a figure, that okay, these many males were there and these many females are there, so that will leave a mark in the mind, saying that the presentation always leaves a mark, like okay, I saw this figure. That's how the information is presented in the form of table listings and figures. Now it always needs to be structured. You cannot just present the information just the way you like. No, there are certain guidelines, there are certain ways, there are certain formats that you need to follow when you join the clinical research industry. So in this industry we have a format specific, that is dealing with the sponsor and the client. So that format is we called as tables, listings and figures. Now tables are nothing but those tables, like where we represent counts and percentages for the categorical variables, and the summary statistics, which is n, mean, standard deviation, that we represent for the continuous variables. Now listings is something called as we just give the patient profile listings, right? Just whatever the data is there, we will just be showing that in a specific format. Now the reason why we present this listings is just to ensure that whatever data is counted in tables, it has to match consistently in the listings, right? And so that we come to know that whatever calculation was done in tables is accurate and representing the same data, and based on this data the tables and the figures are presented. Now what are the stakeholders? Now stakeholders are everyone, whosoever is the department in the clinical research study, including principal investigator to quality assurance, biostatistics, then programmers, then data entry people, then all those people who are doing validation, then data management team, then you have this physicist, then all those monitoring team people, the clinical research side people. So each and every role, whosoever is conducting the clinical trial, they all are stakeholders, and every department will have its own representative from that. Like say we have a regulator representative, we have a clinical research representative, we have somebody from biostatistics representative. So these information that we are presenting in the form of table listings and figures, it gives way to present the results, right? And that's how it helps the stakeholders to understand, like what are the findings and what are the results, whether it is effective, whether that study is safe and efficacy, right? So even if say particular, for example, a regulator person is there, he is a non programmer and he is a non biostatistician, he does not know anything. So his role is to ensure that whatever results are there, it needs to be effectively presented, right? Whatever the trial fundings which are there. So in that way, it's a role of each and every stakeholder to ensure that they do their role, and it is presented in such a format so that you can create, or you can give the meaningful results and the meaningful interpretation. Now understanding the structure of the table listings and figures. Now tables are usually, they are used to summarize numerical data, like say for example demographics, which is their efficacy and safety endpoints. Now this is presentation is only for the oncology table listings and figures, but in general it's overall it's 99% is same for all the therapeutic areas and for all the therapeutic diseases, right? And listings, they are used to provide the raw data, like say for example whatever is presented in the raw data, right, the same you are converting in such a format and you are just presenting by record. Whereas in tables you are summarizing, yeah, you are counting like how many mails were there, okay, so there will be 60 males I have, so only you will see only one record that represents male 60 with the summary statistics, right? Whereas in listings you will see list of all 60 records. Clear? So in this you will have one record, in listings you will have 60 records, and each record will represent each patient what is their demographics information, right, each and every information. So it's an individual patient level data. Even if you have the derived data or you have the SDTM data, so those are used for the listings purpose. Even if you have the Adam data sets, if I want to present the Adam listing, like some pro sponsor and clients, they say I want to see the listings for some domain, so those are also presented. It could be even raw data or derived data if it's a non-seeded study, and if it's a see this study, you will have SGTM and Adam data sets. Now figures, where the graphical representations are used to visually interpret trends, comparisons and relationships. For example, the survival curves and waterfall plots. Now figures, they always leave a mark in a human to remember and recollect. Okay, on that particular day I saw that figure, it was presented somehow like this, but I don't really actually remember, but it was looking something like this. So that impression, the graphical representation it gives, it leaves a mark. And these figures, they easily catch the viewpoint of the audience, right? So that is used to interpret comparisons and relationships. So like say for example, I'm having survival analysis curves, so those survival analysis curves are used to, okay, that what are the chances of the patients for surviving, or how much time do they have to survive more if they consume this specific treatment. So say for example, two treatments are there, they did some analysis and they presented a figure. Now a treatment A is having too much of survival chances for patients to, like survive for another 5 years or another 10 years if they consume this specific treatment. And in the waterfall plot, what happens is, wherever you deal with the oncology trials, in oncology trials mostly everywhere 100% survival curves and waterfall plots are used. Now waterfall plots are very unique kind of a plot and a graph, where you actually see whether the tumor size has decreased after taking the treatment. So say for example, a particular patient is consuming a specific treatment, right? So that tumor size, whatever, say it was around 5 centimeter, so after consuming the treatment and being in the clinical trial, say for example 6 months or 1 year, the tumor size should shrink, it should reduce. So in those kind of scenarios, how to present that, like what was the tumor size earlier and how did it reduced, the percentage change from baseline. So what was the baseline value and what was the value at the end of the study, or like say follow up visit or the end of the study visit, or visit wise, whatever it is. So waterfall plots, it will give you the shrinking of the tumor size for each and every patient, whereas the y-axis is represented by percentage change from baseline, and the x-axis is represented by generally by unique subject ID. So you need to understand first the structure of table, listings and figures. When you get any oncology clinical trial study, be it could be any therapeutic area, 99% the format of table listings is same. It could be even bone cancer or ovarian cancer or prostate cancer. Terminologies will be same because we are dealing with oncology, we are dealing with tumors, and the tumors has to reduce. That is what is the objective. It could be any kind of disease in any part of the organ in a human that relates falls under the oncology study, right? Now step 1 is to understand the study design. Now the very first step is to understand and review the protocol to identify objectives, endpoints and populations. Now what happens here is, whenever you get a protocol, and when you are new to the organization or when you're new into the industry, it becomes very essential that whatever that you are reading, you should first understand, and that's how you find a way to implement, right? So once you have read and once you have understood and your things are clear, you will come to know, okay, so the objective of the study is to ensure that the tumor size should reduce, and these are my endpoints. And generally in the oncology endpoints, the efficacy or objective response rate. So what was the response rate after consuming that specific treatment? Progression free survival is nothing but like say, how to explain in a common layman's language is, say progression free survival. Now when I took that treatment for say 6 months or 1 year, that disease should not progress. Okay, so the progression has stopped, the disease has not progressed, so the tumor size is remain as is. It is shrinking but it is not increasing, or it is at that same diameter, or it is at the same centimeter, but it has not increased the size of the tumor, so it has not progressed. That's the reason it is called as progression free survival, right? Even if the definition also will talk about something like that only. And when you speak about the survival is nothing but like, I'm surviving from the oncology disease where it has not progressed, right? That's the reason it is called as progression free. You, once you understand these terms and terminologies, it becomes very easy to handle any kind of clinical trial. So that's how your objective and the motive should be there. Now overall survival, now this means like overall what is my survival chances of that specific disease, including all the terms and terminologies, right? So these are my efficacy parameters. Now these parameters are usually common in any therapeutic area and any therapeutic disease that relates to the oncology, right? Now I can have cancer in my blood, I can have cancer in my bone, I can have cancer in my ovaries, I can have cancer in my prostate organ, I can have cancer in my eyes, or I can have cancer in my skin, any part of your body wherever it has cancer or it deals with that kind of disease. These are the common key endpoints where it is used. 99.9% everywhere it is used, this endpoints, right? So these are the common oncology endpoints. Now the safety is the incidence of adverse events and grade 3 or 4 toxicities. Now adverse events is something like say, I consumed a particular medicine, I got a reaction by consuming that treatment, right? So after taking that treatment, I got a reaction, I got vomiting, I got headache. So like those kind of whatever events that are happening, instead of improving it is decreasing. So those kind of are called as incidents of adverse events, and the grades are severe and severity and all those kind of toxicities. Step 2 is review the demographics table. Now the purpose is to confirm the population is well matched and representative. Now here I have explained the sample of the demographics table where the median age and treatment age is 65, whereas in treatment B it is 63. So you should ensure that the treatment groups are comparable, in the sense like you should have equal number of population, right? Say for example, if the median age is say around 10, and in treatment B I'm having median age as like say 40, or say around 70. So if the median age is 10 and here if it is 70, then it's not comparable. You cannot compare because like it's not it's not balanced kind of data that you're having, right? So whenever you do any screening or the recruitment at the initial stage of the study, there itself you need to ensure that you are collecting the balanced kind of people, so that your sample is comparable. And whenever that data is collected and it is converted to information, and whenever we present that information in such kind of tables like say demographics, the values should be comparable, right? So say 65 is compared, okay, so median age in treatment A is 65, whereas in treatment B is a 63. It is almost like, the same. So the population of the age, we are considering that kind of people. So here say gender, male is 60, female is 40. So here in treatment B, I'm having male as 58, which is 42 female. So it is comparable. You can compare with each other. It's not like I'm having 60 males and in treatment A, and in treatment B I'm having only 10 males, right? Even if you do this, the results will not be able comparable, and it will not be a good fit, like, to do the analysis. So you need to be very unsure about all these things. So ECOG performance, that is 0, 1, 2. Now 0, 1, 2, they are the values that are given to the status of that ECG performance. So say 0 in treatment A is 50, 1 is 40, and 2 is 10. So same here in treatment B, I'm having 52, 38, and 10 respectively. So the population is well matched and representative. So you need to ensure that the demographics table, it should be in specific format, so that it can be interpreted, right? You can interpret the data and you can easily give the conclusion, and you can easily compare. That's how the objective should be for the any specific table. Now this is just the demographics which I have taken as an sample. There could be many other more tables. Likewise, you can modify, and you can understand the oncology clinical trials wherever you are working with whatever available data that you're having. Now, step 3 is reviewing the efficacy tables. Now, to evaluate the treatment effectiveness. Now, here the example that is shown is the objective response rate, which is ORR, and this is a sample data. Now, when you see the response type, we have complete response, partial response, stable disease, progressive disease, and overall response rate. Now I will explain these terminologies in a very simple language. Say for example, I'm having a disease which is like say a tumor, right? Now that tumor size, it has around say 5 centimeter. Now after consuming that specific treatment, the tumor size should decrease, right? It should decrease, and it should shrink, the centimeter or the diameter of that tumor. So when it has completely removed, that tumor, when it has completely removed, or whether that treatment is responding, or your body in a way, what should I say is, if the body is responding to the treatment, and that treatment is affecting the tumor in terms of reducing the size of the tumor in such a way that it has become negligible, the tumor is not visible, in that such a scenario you can say as complete response, right? Partial response is like somewhat it is equally balanced. It is sometimes it is reducing, sometimes it is not, right? So that is a partial response. You are not getting a full response, but you are getting a partial response, right? Stable diseases meaning like say the tumor is there, 5 centimeter, right? The treatment you are consuming, but what happens is the disease is stable. There is no effect of that treatment on the tumor. The tumor size is not decreasing, or neither it is increasing. So in that scenario, what is the condition of that specific patient? Nothing but stable. So the response type is nothing but your stable disease. Clear? Now next we have the progression disease. So now in the progressive disease, what happens is the tumor is there 5 centimeter. You are consuming the treatment, say for example A, right? Instead of either decreasing, or instead of either increasing, it has become worsened in the sense like it has spreaded in other parts of the organ, right? So the disease has progressed. Now say the tumor was there in your head, now it has spreaded to different parts, it has spreaded to lungs, it has spreaded to other parts of your body organs, right? So in those scenarios you called as progressive disease. It is very simple. Oncology is very interesting and very simple topic, you know, and once you understand the logic and the basics, you can do masters in this kind of a field. And the overall response rate is like, say, comparing to all these things, the overall response is that, including all kind of types. So that's like the grand total or the overall. So now here if I do the interpretation, now treatment A has a higher response rate compared to treatment B, suggesting superior efficacy. Now this is something theoretical statement, ma'am, I don't understand. So what you understand from this is the complete response, like say the response of that tumor by consuming the treatment A, the complete response, the positive side of the reaction, there are 20 such kind of patients, right? Whereas when patients they consume treatment B, only 10 showed complete response. So which is more better? It's a common layman's question. So in that scenario it is 20. So that's why it is a treatment A has a higher response rate compared to treatment B, suggesting a superior efficacy. It means superior efficacy means it is efficacious to consume treatment A because it is showing good complete response, the tumor size is decreasing, and the survival chances of those patients are increasing after consuming treatment A because the response is good, 20 as compared to 10. So this is how you need to understand these values. It is very interesting, you know, once you get into it, it becomes very interesting. Now the next thing is the progressive disease. Now what do you think? It should be the opposite of complete response? Yes. So say here the progressive disease, the disease has progressed to some other parts of the body, right? So the treatment the number is 10, and here the treatment B consuming is 20, right? So when the treatment A is consumed, the disease is not progressing too much in that specific patient, right? So that disease has not progressed in most of the patients, which is 10. But after consuming treatment B, the disease has progressed in almost say around 20 patients, right? So it is quite obvious. Here it will increase and here it will decrease. If the complete response is increasing, then progressive disease has to decrease. That is how the logic you need to apply. And partial and stable, anyways, it will be somewhat hereby same only, but we should always be interested in CR and PD. That's how you can understand these values. Now step 4, review safety listings. Now this is to use to assess the safety and tolerability of the treatment. Now here the example is adverse events listing. So what happens is the grade 3 neutropenia is a significant concern in this oncology study. The reason is this specific AE term, which is neutropenia, has a severe grade which is 3, mild, moderate, severe, right? So mild is 1, 2 is moderate, and 3 is severe. So this specific adverse event is severe no matter the outcome was resolved, but it is related to treatment. It means that after consuming the treatment, the patient got this adverse event which was quite severe, but it got resolved, right? So such kind of statements you can make and you can interpret the specific record that this patient, okay, consumed the specific treatment, right? After consuming the treatment, he got a very severe adverse event neutropenia, which it got resolved, at the later stage of the clinical trial. So that's how you can interpret this kind of listings, and you can understand the values, and you can understand the therapeutic sentences. Step 5, analyze figures. Now here the purpose is to visualize critical results, right? Now figures, they anyways they leave a mark in your mind, so it becomes very easy, like to create. And anyways the oncology figures, they are very interesting, and they are very colorful, like you can represent too many colors. So the first popular figure is Kaplan-Meier survival curve, where your x-axis is your times and the y-axis represents your proportion. So here you will have time, and y-axis you will have proportion of surviving. Now the interpretation here is compare survival probabilities between treatment arms, right? So whenever you see, you will see such kind of this survival graphs, like what are the chances of that patient surviving. So you will see Kaplan-Meier curve like this. So here this is my x-axis, which relates to time, and this is my proportion of surviving. Now the waterfall plot is nothing but my individual patients. Y-axis is tumor size reduction, which is usually percentage change from baseline, and it identifies how many patients achieved significant tumor shrinkage. So say I have this particular figure. So this is my plot, right, for the waterfall plot. So now what happens here is x-axis is my individual patient. So these are my patients. Okay, so now each bar, it will represent my patients. So this is patient 1, patient 2, patient 3, patient 4. So these are my patients 1, 2, then 3. Okay, and then what happens is this is my tumor size reduction, which is generally in the percentage form, percentage change from baseline. So what has the tumor reduced, right? Generally we present the waterfall plot in the decreasing order of patients who reduced. So I will have two columns. One is percentage change from baseline, and another would be my individual patients, right? So first I will sort the data by by percentage change from baseline first, and then the subjects. So I will see that okay, this particular patient tumor size has not reduced, but whereas there are so many patients where the tumor size has reduced. So this is how you can interpret your analyze your waterfall plots. These two plots and figures are, they are very popular, and mostly it is used in most of the oncology trials. Applying this to oncology specific tables. Now efficacy analysis in progression free survival. Now here the table is, statistic is median progression free survival. Treatment A is 12.5, whereas in treatment B it is 8.3. So here you can easily compare. So which is far more better? Obvious 12.5. Why? Because the mean progression free survival is longer for treatment A, indicating better disease control. So if I'm consuming treatment A, the median survival chances for me has increased or to 12.5, which is longer as compared to your treatment B, right? And the p value is 0.05, which is strictly less than 0.05. So the p value is strictly less than 0.05, right? So in that scenario, what happens is the statistical significance is there, and hence the p value suggests a meaningful benefit. So the treatment A is far more better than treatment B, because it is giving good results. It is giving me some time for surviving in this world, as compared to whatever the disease treatment B is there. So this is how you can analyze. Applying this to oncology specific tables. Now here I am having safety overview table. So I am having grade 3 and 4, and these are the percentages. So these are the adverse event types: neutropenia, fatigue, and adverse events 3 and 4. This is treatment A and this is treatment B. Now what happens is the treatment A has higher grade 3 and 4 neutropenia rates requiring careful monitoring. So when you consume this treatment A, the chances of having neutropenia rates, they are high as compared to, like, 3 and 4, which is severe and moderate. So in those kind of scenarios, it requires careful monitoring. So the monitoring of the clinical study needs to be done carefully for these patients as compared to treatment B, right? Tips for interpreting table listings and figures. Now the very first thing is cross check table listings and figures to ensure consistency. Now the question is how you can cross check table listings and figures. It is impossible. It is possible. Like, say for example, I have a demographics table. The male is showing 20, right? So how many records should I have in listings? It should be 20. I should see 20 males, right? And in figure also, when I see, I should be able to see 20. Now say in tables I'm having 20 males, in listings it is 18, and in figures it is showing 21. That means there is something wrong in programming. Okay, it is very basic logic, right? If your data is correct, um, like say for example, if you see some numbers here, male is 20, listings is 19, and figures is say 21. None of the values for the male is matching in neither in table, listings and figures. Now what should you do? Okay, a very big question. You go back to your derived data sets if it's a non-series study. So when you go back to the derived data set, you check the records, like, manually, as to how many males are there and how many females are there. You check your conditions, whatever your condition you are applied, whether you have applied safety population, ITT population or people population. Check the filter conditions and all those. So those things should match. If there is some mistake done in the programming, then it will not match. But if the derived data set is correct, then you go back to the raw data. So when you see some discrepancy between raw data to derived data set, and from derived to tables, listings and figures, you need to find out the traceability as to where exactly the issue is. You have to go back from TLFs to derived data sets, and if the derived data set is correct, then you have to go back to the raw data. And when in the raw data, if you see some issues or any concerns, you have to raise the query to the site, monitoring site. So that's how you can cross check for the consistency. Now, second point is contextualize findings within the study's objectives and clinical relevance. Now, whenever you get the study objectives, especially for the oncology, initially when you work on this oncology, it will be a bit different to, like, understand everything easily and understand everything faster. So what is the first thing you need to do? Okay, you got a clinical. Okay, what is this clinical trial? It is for which disease? Okay, is it for asthma? Is it for diabetes? Is it for blood cancer? Is it for skin cancer? So once you have understood the therapeutic area disease, right? Okay, so asthma is there. Okay, so what is the condition that that patient is not able to inhale, right? Okay, so that patient is not able to inhale, so he needs an inhaler. Okay, so okay, so then next the objective should be what? That after consuming that inhaler, okay, the patient should feel relaxed. His coughing, his sleep disturbance should be less. So that's how you understand the objective. So once you understand the objective, you need to understand the clinical relevance. The very first thing is you first need to understand the clinical relevance. Like, say, what is coronavirus? So how did it happen? Okay, so what is the basic, why it happened? So once you understand that, you will be able to understand objectives, and once you have understood the objectives, you can understand the findings. So the findings should be well within your objectives and the clinical relevance. Now the third top point is use clinical judgment for interpreting borderline statistical significance. Now whenever you give any kind of statistical significance, will always be in statistical terms. Like, say for example, p value is less than 0.01, which is less than 0.05, so we reject the null hypothesis. Now if you talk like this to any common layman person who is like selling a tea on like a particular shop, that person will not understand anything, right? So you have to first convert that statistical significance in terms of like clinical. You add some clinical. Okay, so if you consume this, it will not happen. So in that perspective, you need to use the clinical judgment, right? The clinical importance of your statistical significance. So once you add that information, so your interpretation should be meaningful, right? And whatever the statistical significance interpretation you have done, it should be in alignment with the clinical relevance. It should be in comparable to the clinical terms and perspectives that is present in that clinical trial study. So that's how these are the certain tips and tricks that you can use to interpret table listings and figures. Well, this particular slide is applicable to any therapeutic area, any therapeutic disease, because that's how we cross check the table listings and figures across all clinical trials. And whenever we interpret, we use that specific clinical judgment. That clinical judgment, clinical relevance, everything should be there from the clinical point of view. Only then somebody will understand. Otherwise, like people, the common layman person will not understand. So this is what is the understanding oncology table listings and figures. Please like, share and subscribe. Leave a feedback comment mentioning any topic that you want me to make a video. Looking forward for a positive response. Thanks for watching. Please like, share and subscribe. Leave a feedback comment. Many thanks for your support and having great connection.